Okay, so good morning everybody. My name's Dr Sheila Kanani. I'm the Education Outreach and Diversity Officer at the Royal Astronomical Society. We've been offering these Zoom sessions during the whole of lockdown and hopefully for forever in the future. Today it's a great pleasure to have a guest speaker with us. We've got Dr Massey, who's also at the Royal Astronomical Society, and he's going to be talking to us about aliens and ET and the search for life elsewhere. So I will pass it on to Dr Massey straight away.
Thank you so much, Sheila, and thank you to everybody for joining today. I'm really impressed listening as we set up to where people are in the world. It's great, you know, and I guess if you're in India or Dubai or somewhere, it's probably a bit later in the day, but, you know, fantastic that you're able to join us. So as Sheila said, this is one of the lessons we've been offering, you know, during lockdown, and this nice chance to reach so many people. And I thought I wanted to do this talk because I thought, you know what, I did this to my daughter's primary school just down the road from here, and it went down really well because I think everybody is interested in aliens. Who doesn't want to know if there aren't aliens elsewhere in the universe? What a fantastic thing to think about. So I just want to go through a bit of that today with you and get you to think a bit about that and ask loads of questions about it. So when you think about it, here we go, first, there we go. When you think about aliens, I think we often tend to think about all kinds of different weird and wacky creatures, and that's probably not that far from the truth, but of course we haven't actually seen any for real yet, so we're all using our imaginations. You know, you might think about something like this coming out of a flying saucer, which doesn't really happen, but it's been in a lot of films. Or if you watch Star Trek, if you're older, then you might see these Klingons. Or you might have watched Lilo and Stitch about an alien landing in Hawaii. Or, you know, if you've read some of the books like War of the World about Martians landing, or even this very, very old one from a couple of thousand years ago here shows spider creatures that were living on the moon. So it's been a really long time that we've thought about whether there are aliens, whether we are alone in the universe, whether life is only on Earth, or whether we can find it elsewhere too. And it isn't surprising that scientists are trying to answer that question as well. So I hope you know what this is, but I might ask you a bit about it anyway. This is a picture of the bit of the universe that we live in. It's a good picture because it shows all the planets, and on the left there, does anybody know what the thing on the left is? I'm just wondering if I can see. I can't see the chat box, so I'll rely on Sheila to see if anybody comes up with an answer.
I haven't had any answers yet.
No answers. Any answers?
Oh, yeah, there we go. From the Ferguson family, the sun. Rahul
Yeah.
is the sun. Evans family, Radhika, Salma, all say the sun.
Brilliant, absolutely. This is clearly a good bunch of students who know what things are going on. So our solar system, we've got the sun, our star in the middle, and you can see in this picture just how big it is, and then all the planets stretched out there. So Mercury is closest, then Venus, then the Earth, then you go to Mars, Jupiter, Saturn, Uranus, and Neptune. And when I was young, we had Pluto on the end, but it was demoted from being a planet about 10 years ago. So now it isn't quite to scale. These are all the places, you know, the planets as well as our own in the solar system, and they're all compressed together so you can see the different sizes next to each other. And if you really want to know what they look like, if you were traveling in from deep space and looking back at the solar system, you would see, well, it's not you wouldn't quite see this, but this is the only picture we've got of what the solar system looks from the outside, and it was taken back in the early 1990s by a spacecraft called Voyager 2, and it was on its way to the stars. It will take thousands and thousands of years to get to the stars. I think tens of thousands of years, hundreds of thousands, huge amounts of time. But on its way as it left, it took a picture of the solar system, and you can see here just how tiny the planets really are. Now its camera it couldn't point directly at the sun. You can just see the light of it there because it would have damaged the camera. But the little dots there are the planets, and that's the Earth there, just that little blue speck. So space is really, really big, and there's a lot of space between them. And, you know, the only places we think we can realistically try and find out if there are aliens are looking at planets in our solar system, and also, as I'll say later on planets around other stars. But that's just there to give you an idea of just how big the universe is, and even our solar system, just how much of it is really quite empty. So if you go out at night, does anybody know what the easiest thing to see is? What's the thing that's most obvious and another world like our own that you can see if you look out in the night sky? Any ideas?
The moon?
Absolutely right. Yeah, the moon, exactly. That brilliant orb. You go out at night, it's really, really obvious, and you can't miss it, and it looks like another world. And if you look at it through a telescope, you see craters and mountains and so on. So the moon. So the first place, if we're going to travel away from the Earth to look for life that we might try, is the moon. And this is a picture here of the Earth on the left and the moon on the right. So first of all, you can see how far away the moon is. It's really a long way from the Earth, although it's quite close compared with the stars and the planets and so on. But you could fit about 34 Earths between those two things. So it wasn't really surprising that it took a long time to get there. Imagine traveling 70 times the distance to Australia. That's how far away the moon is. And you can see also it's quite small compared with the Earth. It's about a quarter the size of the Earth. So if I go to the next picture, and it's also the only place though that we've actually been, that humans have actually traveled. So that early Greek writer, Lucian of Syria, his name was, he was writing about whether there were aliens on the moon, and quite a few people have done that in science fiction right up to the 20th century. But sadly, when we got there and the first astronauts were walking on its surface, actually 51 years ago today, I think they were, well, certainly last week, it was very, very, very close to the 51st anniversary, the first people to go to the moon. This is a picture of one of them, Buzz Aldrin, who is still alive, but Neil Armstrong, who was first to walk, he died a few years ago. And you can see it doesn't look like a very habitable place. They have to wear a spacesuit if they're there. It's baked by the sun. The radiation from the sun as well doesn't help. It gets very, very cold at night. There's no atmosphere you can breathe, and certainly no liquid water, certainly no food. So I think we can safely say that's not going to be a very, very good place to find aliens. And sure enough, we've never found anything there. There's no reason to believe that there was ever life on the moon. So if you go then, if I ask you next, where else do you think we might look for aliens if you're looking around our solar system? Any ideas?
Mars comes straight away.
Comes straight up. See, this is such a bright bunch of students we've got on this call, isn't it? Yeah, and Mars is a brilliant suggestion, and it's the other place that people have really wondered about. Now, I should say that, everybody I'm sure has seen the moon if they look up in the night sky. But Mars is a bit tougher, but it's actually going to be very, very good this autumn. So if you're looking out for it in October, November, December, it'll be really, really bright and high in the southern sky. And it'll look like a really, really bright red dot. And if you've got a small telescope, you can see it's a little disk, but it's quite hard to see much more. But astronomers, when they developed the first telescopes, they wanted to look at it, and they noticed that it was a bit more like the Earth than the other planets. So, for example, it's got this big ice cap down here. Now, if you think about poles of Arctic, then we're used to seeing ice. And so they saw that and they thought, oh, that looks a bit like the Earth. And they also saw these other features. This, by the way, is one of the best photos you can get from the ground by someone I know, very, very good photographer. But they saw these dark bits here. And what they noticed was that over the seasons, as Mars went around the sun, these dark bits would get covered over, would disappear, and they would change shape. And quite a lot of astronomers thought maybe this was a sign of plants, growing and shrinking back with the seasons. Now, it turns out that it's actually all this dust blowing around over them, and every so often they're covered up by dust, and then the dust blows away again, and we see more of them. So that's why the features are always changing a little bit. But that said, because there's ice there, and because we know it's water ice, there's been a lot of interest in saying, well, is there life on Mars? Now, I could have added in some pictures. There's loads of stories of Martians coming to the Earth and so on, and alien civilizations on Mars. But we're very sure there's nothing like that there now. But we have sent lots of space probes to have a look. And there are things like rovers like this one. This is a robotic rover driving around the surface of Mars. It's called Curiosity. It's been going for some years now. And it drives around and it sends pictures back to the Earth. And mostly what it sees, by the way, I'd ask this question actually. If you looked at that landscape there with all the rocks and dust and so on, is there anywhere on Earth it reminds you of? What kind of place do you think would look like that? See if anybody's got any ideas.
Yeah, the desert, the Sahara Desert, the desert.
Yeah, this is clued up students here. Yeah, exactly. It looks a lot like the desert. And I think what's nice about Mars, we get pictures like this, and it actually looks like somewhere we could just imagine walking around, like some sort of, well, this looks like a rocky desert. You could imagine going along and picking up some of the rocks and kicking the dust around with your feet. And that's what it's like. The only difference, though, the big important difference, is that it's very, very dry, and it's quite cold at night as well. It gets well below the coldest places on Earth, even in the Antarctic. And as well as that, the air is very, very thin, and it's poisonous. It's carbon dioxide that we can't breathe. So it'd be quite tough for people to go there. And if we did, we would still need spacesuits. But the interesting thing about it, though, is that it might, there's a lot of evidence that it once had lots of water there. So if you go back, say, 2 billion years, 2,000 million years, long before there was any complicated life on Earth, it might have had a big ocean. And we see that when we look at pictures of it from space. And also if we dig down into some of the rocks as well, we see there's water down in the soil. And water is one of the things that life on Earth really thrives in. So, I can see a hand's gone up from somebody there. Sheila, can you see what they're asking? If you could, can you see if they can ask?
Oh, I can't see the hand.
Maybe they lowered their hand again. It doesn't matter. We can take those questions later. It's not a problem. Yeah. So if there was once water there, then, maybe just possibly there liquid water flowing around, which there isn't much of today. We think there might just have been life, and there might still just possibly be life under the surface, but we certainly haven't found it yet. Out of interest, it was interesting to hear somebody from Dubai, I think it was, on the line, because actually the Arab world launched its first space probe a few days ago called Hope, and that's going to go to Mars and survey it from space. And then there's one going from another American one, a NASA one, launching quite soon as well, called Perseverance, and it'll put another rover like this on the surface. And the Chinese are doing one called Tianwen-1 as well. So lots of space agencies want to send rovers to Mars, and eventually we want to send people there too. Now, I think that'll be a long time, but it's possible that many of you on this call certainly will get to see that. I think by the time you're my age, so 40 years time or so, then it's very likely that we'll have people on the surface of Mars.
So we have a question. How long would it take to get to Mars?
How long does it take to get to Mars? Well, if you travel there at the moment with the rockets we've got, it takes about 6 months. And that's the reason I think that we haven't one of the big reasons we haven't sent people there, because if you go there, it takes you 6 months. You have to be on the surface for a whole year, or in orbit around Mars for a whole year, and then you have to return to Earth over another 6 months. So you're looking at a minimum of 2 years round trip. And so that's why, unlike the moon where you could go there and back in a week, it's a really difficult thing to do. You have to take all your supplies, be protected from space radiation, land on the surface, take off again. It's a really hard thing to do. I think we'll do it. And I think before that, we'll probably quite soon, we'll have a mission that brings a bit Martian soil back to Earth, but a robotic one. But it's going to be a while before people get there. And it's just a complicated thing to do. But certainly I would be surprised if in at least 30 years' time it hasn't happened. So okay, so if we go further out from Mars, now as we're getting further away from the sun, it's obviously going to get a bit colder. And so you would think it gets harder and harder to find life. And that's pretty much true. And the planets get very different as well. So Earth and Mars are places you could walk around on the surface. This one, though, first of all, does anybody know which planet this is? Any guesses?
Lots of Jupiters coming.
Lots of Jupiters, yeah. They can't fool this crowd, clearly. Everybody's very clued up. It's Jupiter, that's right. And it's the biggest planet in the solar system. And actually, like Mars, if you go out, actually you have to be quite late at night. I saw it last night. Jupiter and further out, Saturn are both visible in the sky at the moment, low down in the south in the UK. And if you're in somewhere like Dubai, actually, they'll be nice and high in the sky, but it helps to wait till later in the evening to see them. Jupiter's a big gas giant, so it's mostly gas, and underneath that, very, very compressed gas into a strange liquid. If you tried to walk on the surface, you would just sink into the atmosphere and be crushed. So that doesn't sound like a very good place for life to exist, and certainly people couldn't like that. It's also got a big radiation field as well. But Jupiter, because it's so big, I think you could fit about 1,300 Earths inside. It's got a big gravitational pull, and it holds on to loads of moons. I think it's about 70 moons going around Jupiter, and 4 of them are so big they're almost like planets. And this is one of them here. This one is called Europa. It's about as big as our moon, but it's very different. And it's got a big icy surface you can see there on the left, covered with cracks and fissures and things. And we think, because it's so close to Jupiter, and we've seen evidence of this in space probes that have gone past. This is a probe from a space mission called Galileo. That underneath the ice is a surface is a big ocean. So the idea is that maybe it might be 10 kilometers deep, 20 kilometers deep, so much bigger than the oceans of the Earth. And of course, if you have lots of liquid water there today, and it's being heated from inside, I should say that's happening because Jupiter's gravity is stretching. It's so strong that it's stretching the inside of the moon and heating it up, and that's melting the ice and creating this ocean. So it might just be that there are things swimming around in that ocean. Now, we've no way of knowing until we send a space probe there, and ideally sometime actually a probe that goes underneath and swims around in the surface to have a look. But just imagine there might be things going around there. I'm not saying there's fish. We have no idea what's down there. But on Earth, in deep oceans, you do find life, even though it's very dark, and they rely on the heat coming up from inside the Earth. So the same thing might be happening there. And further out, Sheila, I haven't got a picture of it, but further out, there's a moon on Saturn that's got a similar thing going on called Enceladus, and water jets coming off. And, you know, that's another place we could look to.
Just a quick question about Europa. How does Jupiter's gravity melt the ice?
Oh, it's a tidal effect. So what happens is essentially that one side of it is pulled a bit more than the other because gravity weakens as you get further away, so it stretches it slightly, and that's enough. If you stretch the inside of the world, inside of the moon, then that melts it, and that heat then comes out from the interior and melts the ice. So there's a moon closer in on Jupiter called Io, and that process is so extreme that that moon is covered with lava and very, very hot. So not a good place for life, but it's an extreme example. In Europa, it's a bit milder, so it's enough to melt the inside, but not do anything quite as dramatic. And we see that, you know, in different places, but it's that's why people are so interested in going to have a closer look. So now, I don't think, I said earlier on, I don't think there's any intelligent life in our solar system. I think it's really unlikely because I think we'd know about it, or if they're there, they're very, very well hidden and keeping out of our way. But it's not just the solar system we're talking about. There are billions and billions of stars in our galaxy alone, and there are billions and billions of galaxies in the universe. So the odds of there being planets with some life on at least seem to me, you know, really, really high. There must be some life out there. And so that's been another source of interest in trying to answer this big question. We look at things called exoplanets, and that just means a planet going around a star that isn't our sun. And until about 30 years ago, we haven't found any. So astronomers would think there must be planets around other stars. Why would the solar system be so unusual? But, you know, we didn't know for sure. And then in 1992, 93, we found the first planets in orbit around other stars. And now we've found thousands of them. There have been space probes launched to try and see them. We don't see most of them directly, but what we see is that they move in front of their star and the light dips down a little bit and we can see them, or they pull the star back and forth and we can detect that too. And so now we found this story is from last year, the 4,000. I think the number must have gone up by another 1,000 or so since then. So there are lots of places, lots of planets in orbit around other stars. Now, you might think, well, that's a good place to look for life, and it's true, but you also probably have to have the right kind of star as well, because not all stars are like the sun. And if you go out at night and you look at them, you'll see their different brightnesses. That's partly because they're different distances from the Earth, but also some of them are genuinely hotter and brighter. And one's like this one's here on the left. This is called a blue giant star. This is a super hot star. And it's so bright and so hot and so massive that it uses up its fuel really quickly. Now, I say really quickly, it's still at least 10 million years, which is a really long time. But the Earth has been around for 4,500 million, and it's taken that long for us to develop, for us to evolve. So if a star like this exists, is that it has planets going around it, chances are you wouldn't have enough time for really complicated life to develop. And equally, on the right there, this is a cool star. This is a better prospect. It's called a red dwarf. There are lots and lots of these. The main thing with these stars is you'd have to be a lot closer in for it to be warm enough for you to have lots of water. And in the middle is the sun. So this is the sort of, you know, the star we're familiar with. So they're good places to look for life too. And those red stars, the complication is that some of them, there are lots of them in the universe. There's the closest star to the Earth is one of these red dwarf stars. It's called Proxima Centauri, and it's down in the southern hemisphere. It's still more than 4 light years away. So the light from it takes 4 years to reach us. It would still take us tens of thousands of years to get there at the moment. But it's one place where we think there are planets. The only problem with that kind of star is that a lot of them have these big eruptions on their surface. And so if you live on a planet nearby and you have this big blast of radiation, it might not be very good for you. So that's why there's a lot of interest in looking at stars like our sun. And even then, sorry, go on, Sheila.
Just a quick question. What is a light year?
What is the light year? That's a very, very good question. Okay, a light year is the distance light travels in a year, and it's about 10 million kilometers. So a very, very long way. It's about is that right? It's about 60,000 times the distance from the 70,000 times the distance from the Earth to the sun. So a huge distance. And the nearest star is 4 of those away. So a very, very long way away. And that's the nearest star. The furthest stars are thousands of millions of light years away. So ridiculous distances. And that's why we haven't got any easy chance of getting to the stars at the moment. So anyway, what I wanted to say was, as well as getting the right star, you also have to be in the right place, really. You have to be in a place called the habitable zone, which means that the temperature is about right. And astronomers now call it, well, do you remember the 3 bears? So you've got Goldilocks, well, here's the 3 bears, and Goldilocks chose the porridge that was just the right temperature. She didn't want it too hot and she didn't want it too cold. She wanted it just right. And that's what we need with our planets as well. They have to be in the right place, that it's not so hot that the water is all steam and not so cold that it's all ice, ideally, but just right. So you've got a mixture of those things. You've got water and probably a bit of ice and so on, just like we have on Earth. So that's another thing we look for when we're looking for planets. And we think we have started to find some planets that might be like that. You know, these are various pictures I'm just showing you of where they might be. They're just in the right place around their stars. And they're just also, hopefully, the right size as well. Because if they're too big and they're like Jupiter, you just sink down into the surface. That's not going to be a very good place for life to exist. But we have found some now that are looking a bit like the Earth. Now, some of them are a bit too big, and they're sort of Earth-like, but a bit, you know, maybe rocky surface, but a bit too big, and they might have, you know, the wrong kind of atmosphere and so on. But we are starting to find at least a few that are about the right size, as the same size as the Earth. And what we don't know yet is whether they've got the same sort of setup as us. That, you know, they're in the right place around their star. They might be, you know, in that Goldilocks zone, but we really want to know whether they've got the ingredients for life. Now, out of interest, what sort of things do you think you need for life to exist? Anybody want to guess? Very simple things. Think about that.
Air, water, food.
That's pretty much perfect answers, right? Exactly. Yeah, you need air. You need oxygen that you can, for life like us anyway, and at least something like that. You need water as well. Liquid water is really helpful. It might not be absolutely essential, but it's very, very good for life. It allows it to really thrive on Earth. And you do need, you're right, you do need food. You need whatever that life is, whether it's really simple or really complicated, it needs something to eat. So all of those things are the kind of things astronomers look for. And in the next few years, we might, well, this is another picture, by the way, of an alien world with plants growing and so on. You know, they might look completely unlike anything we've got on Earth, but we like to imagine, you know, there's water and the plants going on the side of them. But in the next few years, we'll be building telescopes like this. Huge telescope going to be built in Chile, and it's called the European Extremely Large Telescope. Needs a more original name, I think. And it's going to have a mirror, which is this bit here. Hopefully you can see my mouse moving around, my cursor. This bit here is the mirror that collects the light. And that mirror alone is going to be 40 meters across, which is probably bigger than most of the schools you're going to, or at least the size of your playgrounds. Imagine a mirror that big on this big telescope in Chile. It's being built because we can collect light from these planets that we can't quite see. We should actually be able to see some of them, and we can look at what they're made of as well. We can look at the light and see if there's evidence for oxygen and water and all those things. So we might just find some hints of life in the next few years using telescopes like this one. And there's a couple of other tricks we can use too. One of them, or let me put that out as a question. If you couldn't see that life, how else do you think they might make themselves known to us? How do you think we might know they're out there if we can't actually see them? Any ideas?
Some earlier said listen to them or look for messages, pick up signals, hear them speaking.
That's absolutely right. Yeah, absolutely right. That's exactly what you would do. You'd listen out for them and try and detect radio signals. And that's been tried a few times using telescopes like this one. This is in Jodrell Bank in Cheshire, and it's right here in the UK. And there are also others around the world who've done the same thing. And so they're pointed at maybe hundreds of stars for a while, just to see if we can detect any signals from anybody who happens to be transmitting. And by the way, if you were listening out for TV signals from the world, from the planet we live on, from Earth, they would now be about 80 light years away. So, we would, that covers possibly hundreds of planets. So it's just possible that somebody out there is listening to back episodes of EastEnders as we speak. So, and the other thing we've done is to not just listened out, but also try to communicate the other way. And there's two ways we've tried that. One of them is to send a message like this one on the left. This is sort of digital encoding one. It was sent out in 1973 from a big telescope in Puerto Rico called Arecibo, and it was sent to a star cluster which is more than 20,000 light years away. So, and it was just showing sort of a picture of people and so on. Now, obviously the problem with that is the signal travels at the speed of light. So it's going to take 20,000 years to get there. And if they listen and they want to reply, it'll take 20,000 years for the reply to come back to us. So it's not going to be a very, very quick way of getting an answer. Another thing that's been done is to send space probes out with things on them. They did a job, in this case, the Voyager missions in the 1970s. They explored Jupiter, Saturn, Uranus, and Neptune, and then they left the solar system completely to go out towards the stars. And it'll take maybe 40,000 years for them to reach even get close to any stars. But just in case they were picked up by alien spacecraft along the way, they carried these disks with them. And on the surface of this disk is a map showing where the sun is, compared with a special type of star called a pulsar, just a map in the galaxy. Instructions, if you could understand them, on how to play the disc on, because it's like an old-fashioned kind of record. You put a stylus on, and then an indication of, again, where the sun is. And if I can get this to work, they also then decided they would carry all these sounds of Earth on them. So I'll see if you can hear that. Here's one of them playing now. So you can hear there's bird song and noises from, I think it's supposed to be from the jungle and so on. So if the aliens manage to play the disc, this is the kind of thing they'll hear. And who knows what they'd make of it if they managed to play the disc. I mean, I don't know what Earth what it is. And the other one, if I can stop that for a second, is, I think this one is the one of the wind and, there you go, footsteps and wind and rain and things. Who knows what you'd make of that? Imagine if you picked this up and you had no idea about people or what life on Earth was like. So there we go. So that's then our effort, our basic effort to try and understand life elsewhere in the universe. We're trying to look for it directly on planets like Mars and hopefully on moons like Europa, going around Jupiter. We're trying to look for it in planets around other stars as well, just seeing if we've got those signs of life like oxygen and liquid water. And we're also occasionally trying to listen out for it too. Now, none of these things have worked so far. We've been trying to do this for a very long time. Since the invention of the telescope more than 400 years ago, people have definitely wondered a lot more about this and tried to look for those things, and we haven't seen anything yet. But I am fairly convinced that we'll make those discoveries quite soon. And, who knows, it might be in the next few years, it might be in the next 30 or 40 years, but my guess is we'll find some evidence of some simple life, at least, quite soon. So with that, I'm going to, with this click forward, hopefully it'll click, I need to go back there. So I'm going to play the thing again. This is just going to play throughout. There we go. I think that's probably the way it works. There we go. If anybody's got any more questions, I'd really love to hear them. So thank you so much. Don't know if I can see you, actually. Is the way I can do that, Sheila?
If you stop sharing your screen, and then
I can do that, yeah. And then I can see everybody who's been listening, which would be really great. And I can see there's loads and loads of questions coming up. So.
I've written down a few questions that we got during the talk. So I'll read those out first, and then if there are any other questions, please do type them into the chat. So There's two sun-related ones. The first one was, how close can you get to the sun without burning? And have there ever been asteroids that have sort of crashed into the sun?
That's a couple of really good questions. So the first thing is, yeah, the closer you get to the sun, the hotter it gets. So on Mercury, it's seriously hot, hot enough easily to melt lead. You know, lots of metals would be glowing red hot, and a very hard place for life to be, certainly. The only thing there, though, is that because Mercury, for example, doesn't have an atmosphere on the night side, it's very, very cold. And we think there might actually be ice at the poles on Mercury, deep down in these craters that never have any sunlight. And that's a clue to how close you can get as well, because we've got a space mission going there at the moment called Solar Orbiter, which is not far off the distance of Mercury to the sun. And that's getting hot, but it's got these special reflective shields in place. And so that means behind the shields, it's fairly cool. There's also an American one called Parker Solar Probe that's going even closer. So you can get close, but you have to be very, very well shielded. As for whether asteroids have crashed into the sun, that's a really good question. And I'm not sure. Comets certainly do. And asteroids must have done at some point in the history of the solar system. The only thing is, I think probably if it happens, it would be quite hard to see them, because comets we see, like the Neowise one that's up there at the moment, because they have big long tails, so we tend to detect them. They look a lot brighter. But asteroids, as they're basically rocks and can be quite small rocks, can be quite faint, so it can be quite hard to see them. We know that's happened around other stars, because we've seen that there are the special stars called white dwarfs. This is what the sun will end up like at the end of its life. And we've seen signs of asteroids having collided with those. I can see some private questions that have come up as well. One is about Jupiter again. Do you think Sankra? Was I saying about the name of one of the planets, 4562b? It might be, actually, I can't remember the numbers. Water was listed an answer, yeah. And is Ganymede near Europa? Yes, it is. It's just the next one out. So the big moons of Jupiter go Io, Europa, Ganymede, and Callisto.
Okay, there's
ask.
Yeah. So when we're looking for aliens and we were talking about the things that they need, would oxygen be essential, or would they be able to breathe something else?
It's a really good question. I think that the thing you need is, because there are things on Earth that don't need it. Simple life. I think a lot of these things we think about because we're familiar with it, and we think about chemicals that work well. So if you've got oxygen, it's quite convenient on Earth. There's a lot of it. It allows you to make all these complicated chemicals in your body. And that's also why our life is probably based on carbon, because you can make these complicated molecules. And if you think about something as complicated as your brain, it needs really complicated chemistry to work, so that's probably a lot to do with it. So I wouldn't say it was essential, but I think it's probably helpful. But, you know, plants breathe carbon dioxide, right? So if there's lots of carbon dioxide, that might be a good sign as well. It just depends. Probably the temperature is the most important thing. If it's too hot, then you're not going to have life, because it just isn't going to survive. The molecules that make it up will all break down, and you'll have a sort of goo instead.
Lovely. There's two questions about exoplanets. So are there other solar systems, so exosolar systems? And when we're looking for life on exoplanets, why would it be a problem that the planet would be larger than Earth?
Okay, so there are other solar systems, definitely, because we found lots of examples, like one of the ones I showed you, the pictures of all those. There's at least one called TRAPPIST-B, which has got, or the TRAPPIST system, that's the name of the space probe that found it. That has, I think they detected at least 7 planets going around that system. So there are definitely other solar systems, and they are, and, you know, we just don't know enough about each of the individual planets. Now, the other question was about the size of them. If the planet is bigger than the Earth, the main problem is there's two things. Firstly, the gravitational pull might get higher. So any life that did evolve would have to be quite different. You'd probably have to have very strong bones if you had a skeleton, just to be able to move around. The other thing that happens is you get a big, thick atmosphere, you get more gases piled on, and that might make it more difficult too. But you're right, it's not a deal breaker. It might still be possible, but if the gravity was 10 times what it is on Earth, I think it would be really high, but maybe twice as strong would be fine. Don't know. You know, we like to look for things that are like the Earth because it's what we know. Oh, I can see another private question on this one, actually. How many meters is it to get from the sun to Proxima Centauri? A lot is the answer. It's I'm just trying to do the maths in my head. It's about 45 million kilometers. So that would be 45,000 million meters. A long way. So 45,000 million meter rules.
It's hard to imagine numbers that large. Okay, what kind of simple life forms do you think exist on other planets or moons?
Well, if they exist, I mean, if they're simple, then they're probably going to be like the simple things you have on Earth. So simple single-celled things that are like bacteria or something of that sort. They might not, you know, there might not be anything like the stuff we're familiar with, but simple bacteria type things, you know, simple things that just multiply, and they probably consume some of the chemicals nearby for food, and then they spurt out goo, and that's probably how they're living mostly, you know. And that's, even finding that would be a huge discovery. So there's a massive amount of interest in this, and I think it's probably the type that we'll find first of all. If we're going to find life elsewhere, it's going to be something like that. You know, also, you know, intelligent life is a really, really big thing to look for, but I suspect that we're much more likely to find that simple sort of goo-loving bacteria than anything else.
What would you personally send into space to let aliens know that we were here?
That's a good question. The real problem with this is that space is so big. So if you send it into space, the odds of anybody finding it are not very high. So they'd have to, you know, you'd have to have a situation where it probably went towards a planet where you knew things are living. And the other problem, as I mentioned before, is it takes tens, maybe hundreds of thousands of years to get there. So what, I don't know, what you could do, I suppose, if you really wanted to announce your presence, is you'd find a way of maybe making a really bright systemic light and switching that on and off. If you could find a way of doing that that wasn't too destructive, you know, you could explode a nuclear bomb in space. That's probably not a great idea. But if you could find a way of doing that, that might let people know we were around. I mean, the only problem is they might just think it was something the sun was doing. So you'd probably have to keep it going for a while and do something like Morse code or that kind of thing. The transmissions as well are another effort, but again, you know, tens of thousands of years before most people pick anything out there picks them up.
That's a great question. And then Max had sent a question in previously asking about if there are aliens, could they be male and female, girls and boys, and what kind of skin color do you think they might have?
Yeah, that's a fascinating question, because not all life on Earth has male and female characteristics. I guess the more complicated life does, and that's probably just been an evolutionary convenience. You know, for whatever reason, it became more convenient for us to reproduce by having male and female. But simpler things don't. And even some fairly advanced creatures, I'm just thinking about some amphibians and so on, they can change sex, can't they? And that kind of thing. So it's probably not essential. I can't see why it would be. As for the skin color, well, that's a really good question. I guess if you, on Earth, it's related to, well, originally where populations were, and as they move further north, they get lighter skin because they need more vitamin D in the summer and that kind of thing. And lighter skin makes it easier to get that. Whereas if you're in the tropics, you need more protection from sunlight. But so your skin tends to be darker. So maybe you might see the same thing happening with aliens. It's a good, if they were near the equator of their planet, maybe they would need that protection. And so maybe they would see the same sort of pattern. But so yeah, it's a very good question.
Mm-hmm. And then two about sort of talking to aliens, I guess. When was the last time we sent a message into space? And if there are aliens, why have they not come to Earth? Or do you think maybe they have already landed on Earth?
Well, those are both very good questions. I think the first one, I can't remember if there's been one since that 1973 transmission, a deliberate one, that we have been accidentally or just routinely sending stuff out into space, because all the TV transmitters send signals into space. So all of that stuff escapes the Earth, goes out to the stars. It just carries on all the time. And all the other transmissions we've got would do the same as well, although they might be very, very weak by the time they get to the stars. Now, as for sorry, what was the other question, Sheila? I'm just trying to...
Do you think, or if there
are aliens here? Yeah.
Have they come already? Yeah.
Yeah, I don't think they have. If they did, they'd be super good at concealing themselves, I suspect, because Nobody's really seen it. And I know you see all these reports of UFOs and the rest of it. Well, there are unidentified flying objects, but they end up being identified. You know, Venus, Jupiter actually is another thing people think. Space station overflight, strange planes, all these kind of things. But I don't think anybody's really actually met or spoken to an alien. It would depend on their attitude. I think if it might tell us that space is very big and it's impossible for them to get to us. It might tell us that there just aren't any intelligent ones, and maybe that's telling us that we are alone and there's only simple life out there, perhaps. So we don't know, but I think the answer is that they've certainly chosen not to so far if they're out there and able to reach us. And it was asked by, it's a very clever question, because it was asked by, there was a scientist, Enrico Fermi, in the last century who asked that very same one, said, why haven't the aliens come to visit? And they haven't. You know, whatever, for all the science fiction stories, all the films, they just haven't. Now I can see a private question, which is, is Kepler 452b's land brown or green? That's one of the planets I showed. We don't know, because we don't really know what these planets look like. Most of the things I've shown you there have just been illustrations. So anyway, keep them coming.
Yeah, so there's one here saying it's quite deep and meaningful. How do we fundamentally define what life is? What are the basic characteristics we look for to conclude that something is living? And is this definition universally accepted?
Oh, that's a very, very difficult question, actually. I think the answer is generally we talk about things that are able to take in resources, so take in food, energy sources, you know, excrete things and reproduce. And so that kind of self-sustaining thing where it keeps going and makes more of itself is not a bad definition. Some things are on the threshold. So I think to refer to at the moment, thinking about the pandemic, but viruses are considered life just about, but they depend on other life to keep going, so they can't exist on their own, whereas bacteria can. So there's different arguments about exactly what constitutes it, but and there are some chemicals that almost reproduce on their own as well, that make copies, but they're not quite considered life. So I'd have to look up the details, the definition, but that's a lot to do with it. It's not, and not everybody, I'm sure there are people arguing about exactly what defines it.
And it might be different in different places in the universe.
Exactly. How hot is the sun? Someone says, about 5,500 degrees Celsius, roughly. And sunspots are a little bit cooler. That's the surface of the sun. The inside of it is super hot, like 15 million degrees.
Very hot. I've got a question about, well, we were talking about, are there aliens on Earth? What's your opinion on things like octopuses? Could they have come from space?
Well, I mean, probably not, but they do look sufficiently weird. And I suppose it's also it's a nice argument, isn't it? Because you think, well, if you think that life elsewhere in the universe has to look like us, well, things like octopuses and squids and so on are an example of how life looks so very, very different. No, but I think credit to evolution. I mean, the amazing diversity of life on Earth is that we end up with things like octopuses and totally weird-looking creatures. I mean, also, you know, think about how different a spider looks to us, and that's all. You know, they're all operating on DNA. They're all fundamentally connected. And if you don't have that blueprint, that little complicated molecule in all of your cells, DNA, in life elsewhere, well, there probably have to be something else like it, I guess. Someone's asking can there be other planets in our solar system? Well, there definitely are. There's the answer. There's 7 of those. How many moons are there altogether? Lots. In the solar system, I don't know, 150 or so at least, I think. No, probably a couple of hundred. So lots of places, but only a few of them are places where we might think there might be life.
A couple more questions. So why are larger hot stars blue? If they're hot, shouldn't they be like fire?
That's a very good question. Well, the answer is that we think of things like, we tend to think blue is a cold color because we're used to ice. But actually, if you heat things up, if you think about it, take a bar of metal, you heat it up, it will glow red eventually. And then if you make it super hot, it will grow white hot. Now, if you could make it much, much hotter, and that's really hard to do on Earth because the metal would probably turn to gas for a start, it would glow blue. So the hottest things in the universe are blue, or even so hot that they're ultraviolet, but we can't even see them. They're so hot. So that the light coming at them is so hot, we don't, they look blue, but most of it is even hotter than that. So the argument in astronomy is that cool things tend to be red, and hot things are blue.
It's like the opposite to what we think of in colours. And then there's a question. So if dinosaurs got wiped out by a meteorite that crashed into the Earth, do you think there was life on the meteorite, but that got burnt up as it approached our atmosphere?
Good question. People think about this. There probably isn't life on things like asteroids, because they're too asteroids. They're too small to hold on to things like an atmosphere and so on. So it would be very difficult for it to live on it and function. It would be a really hostile environment, because that life would just be in the vacuum of space, or even inside the asteroid. They wouldn't have any water or anything like that, or much of a heat source. So it would be difficult. Some people have said that maybe you could get, say, an asteroid or a lump of rock knocked off Mars, say, and brought to the Earth. It would go around the sun for possibly thousands, millions of years, and then crash into the Earth and bring things that way. And also that things could have got knocked off the Earth into space and dropped on places like Mars. So it is a possibility. We just don't know the answer at the moment. But probably the one that knocked out the dinosaurs, no, when that came to Earth, that would have just been absolutely catastrophically destroyed. It would have completely vaporized and been scattered across the Earth, and in the process, destroyed much of the surface of the Earth as well. So it was a huge explosion. It's very unlikely any life would have, if there was life on that object, that it would have survived.
Okay, do we have any more questions?
I can see a couple of questions in the chat box here, which is, what's the biggest star in the Milky Way? Can't remember its name, but there's one that's almost as big as this solar system, as far out as Uranus, I think. Absolutely huge star, huge cool star. The other one is, if there is other life, could they make material we don't know about? Well, if they were, I think the answer to that is yes, possibly, actually. By the way, if you use the chat box, feel free to register it with everyone, so that everyone can see it. But it's, quite possibly, if there's intelligent life out there, it could be completely different. If it was much more advanced, I've no doubt they'd make things that were materials and technology that was very different to ours.
Great. Okay. Last chance for questions.
Questions fine too.
There's been some fantastic questions today. While you're just having a final think, we do have another primary session in August about the Earth and fossils and geology of the Earth and how the Earth has evolved. And we do have another secondary session the day before, I think that's the 12th of August, about Jupiter and the spacecraft, the Juno mission. So have a look at our website and do sign up for those if those sound interesting. Oh, and we have a preschool session as well a couple of weeks after about aliens again. So if any of you have younger siblings, then they can sign up for that one. I don't have any more questions coming through to me. I don't know if you've got any more coming through to you. Oh, there's one more, sorry. If there is life on Mars, when volcanoes erupt on Mars, would life still exist?
Okay, well, volcanoes on Mars aren't erupting anymore. So there are really, really big ones from its ancient past. But now we don't think there's any active volcanoes. So if there is life on the surface, or more likely probably underneath, because it's a bit harsh on the surface, it might be down in the rocks at the top, then the life would probably be okay. But there's not much chance of a volcano erupting on Mars now anyway, because I think the inside of it is much more solid and cool than the Earth's is. So on Earth, we've got all this lava and stuff inside, but magma, that liquid rock that gushes out as lava, but you haven't got that on Mars. So that's one thing you would be safe from on the surface of Mars. Oh, I can see one more chat box on there. Are there any aliens on Jupiter? Not as far as we know, although interestingly, people wondered about that. I think in the 1950s, they imagined these sort of floating gas bags moving around Jupiter's atmosphere, but probably there isn't, because it's got a really strong radiation belt, and it's probably a very difficult place for it to be.
But there could be life, not unintelligent life, on the moons of Jupiter, perhaps.
Exactly, yeah. It's the moons are the places we'd look for, and there could be moons around planets around other stars as well. That might be, there might be the same setup there as well, but they're just a bit harder to find. So to look at those, we need better telescopes, really.
Connected to the Mars volcano question, what if there was life on Mars at some point in the past?
Well, if there was life on Mars, the interesting thing to do would be to look for fossils. And if we ever send people there, I think that'll be one of the jobs they've got, is to look at the rocks where they think there might have been, let's say, lots of water in one of those oceans, or in one of the places where we found what looks like a dried up river, and look at the rocks and take them and look at them under a microscope and see if we can see any tiny fossils. You're probably not going to get evidence of anything big, because if it was active that long ago, then maybe it would be like the Earth was at the time, and there would only be quite simple life. But it would be a really good thing to do, to take those rocks and see, is there evidence of fossils there? Wouldn't that be amazing? I mean, that would be a great thing to do. Go to Mars and be the person that finds evidence of past life on Mars.
That could be you guys. I don't think it will happen in our lifetime, but it could happen in some of the audience's lifetime. Fantastic. I think we'll end there. If you do have any questions that you think of in the next, whenever really, feel free to email us or get in touch with us via the Eventbrite links that you've got already. And do have a look at our website if you want to sign up for the next few sessions. And also, when you start school in September, do mention these sessions to your teachers, and we would be happy to do sessions like this with your schools as well. So I'd just like to say thank you for you guys for coming today. And thank you for Dr. Massey for a really interesting and thought-provoking talk about aliens and our solar system. And hopefully we'll see you again soon. And in the meantime, stay safe and stay well. Thanks, everybody. Take care. Bye.